Is brain-to-brain communication possible with Neurotech? Imagine a world where thoughts could travel directly from one brain to another without speaking or typing. It sounds like science fiction, but the truth is, scientists are making progress in this area. Today, we will explore if brain-to-brain communication is really possible using neurotechnology. Right now, researchers have built simple systems that let two people share basic signals. These systems use brain-computer interfaces, or BCI hardware, to read brain activity. The BCI captures electrical signals from the brain, often with devices placed on the scalp called electroencephalography, or EEG. These devices are non-invasive and cost around a few $1,000s each. They can detect electrical patterns generated by neurons firing in the brain. Once the signals are captured, they are processed by software that encodes the information. This is where core neurotechnology principles come into play. Advanced algorithms analyze the signals and translate them into commands or messages. These signals are then sent to a computer-brain interface, or CBI, which stimulates the recipient's brain. The most common method for this is transcranial magnetic stimulation, or TMS, which uses magnetic fields to activate specific brain regions. TMS hardware is larger and more expensive, often costing tens of thousands of dollars, and it requires trained operators. When the signals reach the receiver's brain through TMS, they can induce simple perceptions or decisions. For example, one person might send a signal to press a button, and the other person receives a magnetic pulse that makes them feel a sensation or see a flash of light. This process has been demonstrated in laboratory settings with two humans performing simple tasks together. However, transmitting complex thoughts, detailed sensory experiences, or rich conversations is still far off. The current hardware limitations, such as the resolution of EEG signals and the precision of TMS stimulation, restrict the amount of information that can be exchanged. Researchers are working on miniaturizing devices, improving signal processing, and developing better stimulation techniques to make brain-to-brain communication more practical. In the future, we might see systems that allow multiple people to collaborate directly through their brains, or help individuals with disabilities communicate more easily. But ethical concerns about privacy, consent, and data security are also important to address as this technology advances. So, in summary, brain-to-brain communication is possible today in a very basic form. It relies on BCI hardware to read brain signals and CBI hardware to stimulate the brain. While it is still limited and experimental, ongoing improvements in neurotechnology components and principles are opening the door to more sophisticated and seamless brain communication in the future.